Hudson Show. Beyond her viral fame, she is an extraordinary educator, innovator, and advocate for science outreach. She is a Texas A&M Presidential Professor of Teaching Excellence and the inaugural holder of the ML. You guys are getting excited. This is good. It's good. It's good to be excited. But be excited and silent. Yeah. She also leads groundbreaking research on how outreach programs impact university students funded by the National Science Foundation. When she's not captivating audiences around the world, she's organizing Texas A&M's Physics and Engineering Festivals, where thousands of visitors get to experience the wonders of science firsthand. Her passion for teaching has earned her numerous national awards, including the 2023 APS Nicholson Medal for Outreach, the 2024 AAPT Halliday and Resnick Award for Teaching Excellence in Undergraduate Physics Teaching. So get ready for an electrifying performance. Put your hands together for Dr. Tatiana.
People often ask me, what is my favorite demonstration? That one. Imagine this. 5 barrels with water, 5 Coke bottles with a little bit of liquid nitrogen. What will happen? Liquid nitrogen will evaporate, expand, and turn into gas, and nitrogenous gas occupies 700 larger volume than nitrogenous liquid. The result? A beautiful explosion with 1,000 plastic balls that, by the way, are collectibles. This is the grand finale at Texas A&M Physics and Engineering Festival, which will be next Saturday. Everyone is invited. And you know the best part? That thousands of people are cheering physics, science, engineering. And that's just priceless. But I never thought that I would be called TikTok professor or YouTuber. That's crazy. When we started, we never thought that our videos will go viral and accumulate over 1 billion with a B of views on social media. And you know, for us, hosting these videos, creating these videos for people, is just part of our passion, making physics, science accessible and enjoyable for people. And you don't need much. You don't need some sophisticated equipment. Just take a bike wheel. Going wheel on the road. What will happen if I remove my hand? Really? 3, 2, 1. So frustrating. Great. Okay. Now we will change just one thing. Kylie, we will change just one thing. We will start spinning it. Is gravity still there? Check. There. Okay. We start spinning it. 3, 2, 1. It is And when it slows down, it will fall. Now, when you hold your cell phone, think about it. Its operation is based on fundamental laws of physics. Moreover, every single part of it has been, at some point, a discovery done by physicists, and many of them received Nobel Prize for this. But what happens when physics is ignored? 1986, Challenger exploded just after takeoff, killing all 7 astronauts on board. What happened? What was the reason of this tragedy? Rubber O-rings became frozen. The launch was in Florida in January. It was early morning and it was unusually cold. So rubber O-rings that connected different parts of the booster became brittle, and hot gas started leaking through them and finally exploded through the fuel tank. I have this experiment for you. I have a wrecking ball, Robert. Do you see it? No? Okay. We can go to camera now. What happens if I freeze it? You're fine. 3, 2, 1. You're fine. You know what the good news? The good news that when rubber warms, it will regain its elasticity. It will become elastic again. It doesn't happen. Now you're not fine, you need to catch it. This does not happen with living cells. Living cells, clouds. By the way, do not allow people to freeze me. Why not? Here is nice clouds. They go in liquid nitrogen. Oh, look at this cloud! It's water vapor, water vapor, water vapor. Incarnations are boiling like crazy. We will wait a little bit. And while we were waiting, we will have a trash can right here. Nice auditorium with a trash can front and center. Okay, now I take them out. Please step back. Very easy. Oh, look at this cloud. Enjoy. Isn't it a nice cloud? Just work me. But you know what? Clouds become brittle at low temperature, and they do not come back because now the water is frozen. That's what I do with clouds that my husband brings me. Now, I froze everything with liquid nitrogen. What is liquid nitrogen, by the way? You're sitting and breathing there. Are you still breathing, people? Yes? What do you breathe? That's it, just oxygen? You're breathing air. And air is mostly nitrogen, right? So what I had here was liquid nitrogen. Nitrogen as liquid. It's basically liquefied air. Now, let me take a long balloon. And what I want to do, I want to put it in this little flask. Do you think I can do that? Yes. Come on, you people, tell me what should I do? Yes, cool it down. I need to cool it down. The motion of molecules will slow down. Ideal gas law, you know that, right? Pressure will drop in theory. Let's see. 3, 2, 1. If you see any change, let me know immediately. Do you see any change? What's happening? Where does air go? Where does it go, people? Where? It stays in. Pressure drop, it needs small volume. Yes, we did it. Here we go. Here. Loud, you never know what's going to go. Yes! You cannot believe what I will do next. I cannot mess up with the next demonstration. Can you take this from me? Thank you so much. Now I have 2 balloons. 2! It will be competition, a race. One is nice orange, but the second one is balloons. Like, so what I'll do, I will pour liquid nitrogen on both. What will happen to the balloons? Tell me. They will shoot in. Yeah, we know that. The question is, which one will swing first? Which one will win? Which one will be the winner in physics demonstrations of Alexander Pelkos? Of course, Robert will win. No doubt about that. So, help me there. Ready, set, go! My lunch rings for nothing, just nothing. I pour and there's still some amount of gas and orange. How did I do that? What did I do? There are things right there. What did I do? Shout! I put different gases in these two balloons. You're right. What did I put inside this one? Just regular air. What did I put inside this one? Oxygen. Do you see that boiling temperature for oxygen is a little bit higher than boiling temperature for nitrogen? Do you see that? Yes! So with my liquid nitrogen, I was able to convert all oxygen inside this balloon to liquid oxygen. And oxygen is liquid, takes smaller space. Yeah, and to nothing. Okay, so we did that. Now, have you heard about trains and cars that levitate over the magnetic rails? I will show you this experiment. I will show you superconductivity. Do you see this magnetic track? And now I will take a material that is a superconductor. And if I just show you a superconductor, you probably won't be impressed. Just some piece of ceramic man-made material. But if I cool it to the temperature of liquid nitrogen, it will become a superconductor. How does it do that? It's fine. It's fine. Yeah, just fine. And I want to show you today goes one on another. Let's see. Just go. Oh, look at this. No, it's still going. But you're right. What will happen when it warms up? It will not be a superconductor anymore. So, first of all, we need to cool it to the temperature of liquid nitrogen. If you cool it to the temperature of liquid nitrogen, it conducts electric current without any resistance. And you see, it's not only levitating, but it also stays on track. How does it know where to go? Because this magnetic field from this magnet penetrates the superconductor in the form of tiny tubes of the magnetic flux. And these tubes, like tiny microscopic fingers, keep this superconductor on track. Do we go big? Let's go big. Let's put it, I take it east, cheer me up! Upside down. Okay. Now, which one is cold? By the way, one of you needs to find a material that behaves as a superconductor at room temperature. Nobel Prize is guaranteed. Don't forget to send me an email, okay? Okay, so now I will take a superconductor. Do you see that magnets are now upside down? Do you see that? Will it move? Now, you can see it. That's wonderful. Now I will show you several experiments that you will do for your birthday party. How does this sound? Sounds like a plan? Yes? First of all will be Bernoulli's this one? Okay, sure, let's go for space program. No doubt, let's go for space program. This is my spacecraft. I don't know how yours look like, but this is mine. It can spin. I can go there. If I fall, I don't want to fall on you. That's how it should go down. Okay, my spacecraft. And what I want to do, I want to change the orientation of my spacecraft. the bike wheel. So, we start spinning it! I go into my space car. Give it to me! And nothing. Now I put it upside down. Wow! I'm spinning! And I stop. You still control the flight. How does it work? It's the fundamental law of nature. Law of conservation of angular momentum. Sort of conservation of rotational motion. Remember, I was holding the right wheel like this? Nothing happened. But when I put it upside down, the platform, and the bike wheel, we started spinning to compensate the change, to keep the rotational motion the same. Okay? Next will be Bernoulli's principle. That's what you need to do for your birthday, that's for sure. So what's Bernoulli's principle? You probably know this. If we have an airflow, a streamline, then high speed of the airflow means low pressure. How can you create high speed of the airflow during your birthday party? Let's see. Rule number one, close the loop. Close the loop. And we will close the loop. And I will create high speed of the airflow. Probably you're not ready for that. I will do it this way. Don't worry. Okay, so now, can you put this ball? Force from high pressure to low pressure that brings it back into the airflow. Now I need 3 volunteers from close row. Come, let's go like 1, 2, 3. 3, yes, 3. Right? 4. Okay, 4, let's go like. We will employ everyone. Let's go like. Are you coming? You don't think it's going to pass? That's the line. Come here. So do you have this at home? Yes, good job. What's the problem? We cannot get students. That's fine. That's fine. I took it from College of Medicine many years ago. It's now Now the one piece on this side, thank you so much. Our microphone is falling, everything is falling. You will be fine. Stay here. You will operate the lead blower. Are you ready for that? Why don't we move there? In which I go step, 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 step. Don't fall. You have wonderful shoes. And you're safe. Very good physics. You're here. Do you have this at home? Okay, don't laugh. This is civics experiment. Part of the story, small part, why we have airplanes flying. Okay, toilet paper goes on. And now you're ready. Come here, don't do nothing. Thank you. Now, tell me something. If we blow over the top of this toilet paper, where will this end go? Up or down? Up, down, down. Now, let's think about it. We create high speed of the airflow. High speed, low pressure, higher pressure underneath. So there will be uplifting force and the airflow will be pushing toilet paper forward. Let's do it! potato. We did it. Just tell your parents to be very careful to get rid of this potato, do this, and we all are safe. Uh-oh. You're fine. Now, don't throw away this potato, because now I will teach you. When it is really stressful, you have your exams, you have your competition, you need a stress-relief exercise in the great physics experiment. Take a straw, and you know the straws, plastic straws are not sturdy enough to pierce the potato. But if I cover the top, if I create additional pressure, then, aha! You can make a 45, you can make a cake. Do it, aha! What else you can do at home? You come home and you take a bath your dishwashing machine. No, don't do that. Your parents will not like it. But you can buy a corrugated tube, you see? And then, listen. You can play music, create your own band. Just stay far away from each other, okay? Okay, great. Next. And bubbles. Why bubbles? Bubbles. You like bubbles? Everyone likes bubbles. Watch me. They sing. Great. Now watch. What's happening? I have dry eyes there. Just a little bit of dry eyes. Why with your parents in HBO Kruger? You come home, you make fish out of your aquarium, don't forget that. Then you put dry eyes, and then let's think about it. Dry ice evaporates, turns into carbon dioxide as gas. It's like a helium balloon. What happens with your helium balloon? It flies up because it is less dense than air. So these bubbles are less dense than carbon dioxide. There is buoyancy force that pushes them up. There is force of gravity that pushes them down. And if these two forces are equal, look at this. Floating bubbles. Do it for your girl. And you know, at Texas A&M, we like to go big. Are you ready to go big? Let's do it. Do we have boiling water? We have liquid nitrogen. Boiling with bubbles? Because we need to go big. Thank you so much. So we put boiling water here. More? Good. More. And now, I will take liquid nitrogen that is at 400 Fahrenheit. 400. Colder than temperature of my skin. People, you need to cheer me up. Cheer me up. Alright. All together. Thank you so much. Thank you. Thank you. All together. 3, 2, 1.
Another hand. If everybody can please stay seated, we just need a few minutes to clear the stage. And I don't know